As promised, I'm going to talk through a couple of these examples of finding all the zeros after going through the rational roots or the rational zeros theorem to get a list. Just to do a couple more examples, talk you through those, and then I'll write up solutions for the rest of them and get those posted on Moodle for you. All right, so we've got this f of x is equal to 2x cubed plus 13x squared plus 26x plus 10. So the first thing we'll do here is get our possible rational roots. So remember, to get your possible rational roots, you look at the factors of the constant. So we'll do the factors of 10. Those are 1, 2, 5, and 10. And then we'll also look at the factors of the leading coefficient. So we want the factors of 2. That's 1 and 2. And then remember, to get all your possible rational zeros, we will form all of the fractions that we can by taking the factors of the constant, so in this case, the factors of 10, and put it over all the possible denominators, which will be the factors of 2. So, and then we do plus or minus all of those, because it could be positive or it could be negative. So we'll do 1 over 1, 2 over 1, 5 over 1, and 10 over 1. And then we'll also do 1 over 2. 2 over 2 is 1, which we already have in the list, so we don't need to relist it. 5 over 2, and then 10 over 2, which is 5, and we already have that in the list. So we only have 6 possible zeros, and then plus or minus those, so I guess technically we have 12 possible rational zeros. So what we need to do is figure out which of those might be the ones, which one or ones might be what we want to use. So to help us out with that, we'll get a graph. I'll just pop over to Desmos real quick. See if I can remember what the function was. It was 2x cubed, and I'm going to have to flip back over to my screen because I've forgotten already what the other coefficients were. It was 13x squared. Oops, got a mess here. Plus 13x squared plus 26x plus 10. All right, so I see this 0 right here, and actually on Desmos is nice. If I hover over it, I see negative 0.5, which is negative 1/2. So I'm going to use that to start with my factoring, my synthetic division, if you will, to use that negative 1/2, run it through, and see if we can reduce this down to our quadratic. So flipping back over here to my work, I'll put negative 1/2 up here. Our coefficients are 2, 13, 26, and 10. Bring down the 2, multiply negative 1/2 times 2, we get negative 1. Add down, pardon me, we get 12. Multiply again, negative 1/2 times 12 is negative 6. Add down, we get 20. Multiply, we get negative 10. And add down, we get 0. So, in fact, negative 1/2 is a 0. So right now, we have our f of x equals, we have f of x is equal to x plus 1/2 times 2x squared plus 12x plus 20. Notice that in this factor, the 2x squared plus 12x plus 20, we can take a 2 out of everything. I'm going to go ahead and do that. You don't have to do that when you put it in the quadratic formula, but I might as well just go ahead and factor it out. It'll make my arithmetic a little simpler later. So I've got 2 times x plus 1/2 times x squared plus 6x plus 10. And this is the piece that I want to break down a little bit more. This does not factor, at least nicely. It doesn't factor into, like our usual trying to break it up into two binomials and looking at factors of 10 that would add to 6. That doesn't work for us. So we'll go ahead and set that piece equal to 0 and use our quadratic formula. So quadratic formula again is negative b, so we get negative 6 plus or minus the square root of b squared, so 6 squared, minus 4 times a, which is the coefficient on the x squared, times c, which is our constant, and then divide it all by 2 times a. So we get negative 6 plus or minus square root of 36 minus 40 all over 2. So underneath the radical, we'll get a -4. So we've got -6 plus or minus square root of -4 all over 2. We know that the square root of a negative tells us that we're going to have an I, and square root of 4 is 2. So we get -6 plus or minus 2i all over 2. Finally, I can break that up as -6 over 2 plus or minus 2i over 2 and get -3 plus or minus I. So finally now, well, a couple of things. One, we now know all of our zeros. They're -1/2 from the work that we did up here. It is also -3 plus I and -3 minus I. We can also go ahead now, and even though I said it didn't factor earlier, what I meant was it doesn't factor using real coefficients here. We'll have to use complex coefficients to do that. I've got my 2 out in front. I've got x plus 1/2 still. This now is x minus -3 plus I, and then x minus -3 minus I. Because remember, again, if a number is a 0, x minus that number is a root. So this part here is finding all the zeros. This part here is what we call writing f as a product of linear factors. Let's see if we can do another one. This one we may have done in class, but let's just go ahead and go through it again. First thing, let's do our list of possible rational roots. First thing we find is our factors of our constant. Factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. We also find our factors of the leading coefficient. Well, that's really easy in this case because the leading coefficient is 1, so we just get 1, which also makes our list of possible rational zeros really easy because we only have one possible denominator. This, remember, your leading coefficient is your denominator. Denominator of 1 just means that we have 1 over 1, 2 over 1, so we just have essentially the factors of 24 as our possible rational roots. Now again, we will get a graph to help us figure out which possible rational roots might actually work. So let me get over to Desmos again. See if I can remember those numbers. We have x to the 4th minus 4x cubed minus 7x squared plus 22x plus 24, I think. Let me just double check, make sure I remember the numbers correctly. 1, -4, -7, 22, and 24. Good. Okay. So we got lots of choices on this one. Notice that we've got -2. Looks like we cross at -2. Looks like we cross at -1. Looks like we cross at 3. Looks like we cross at 4. We only really need a couple of these because remember, again, we're just trying to knock this down to a quadratic. So then we can get to the quadratic and either factor the quadratic or use the quadratic formula. So going back over here, we said -2 and -1 both worked. Again, I could use any of them that I wanted to start with. So we'll just start with -2. My coefficients 1, -4, -7, 22, and 24. Again, your synthetic division process is bring down the first number, and then it's multiply and add, multiply and add, multiply and add. -2 times 1 is -2. Add down gives you -6. Multiply down gives you 12. Add down gives you 5. Multiply gives you -10. Add down gives you 12. Multiply over -24. We get 0, and we're done. We started with our 4th degree polynomial, right? We start with that 4th degree. We've run through one synthetic division. Remember, the synthetic division really means we're dividing by x plus 2. If I divide a 4th degree polynomial by a 1st degree polynomial, I'm now at a 3rd degree polynomial. We said we're trying to get all the way down to a quadratic. Let's do this again for another thing that we suspect might be a root. Let me just flip over real quick. We said that -1 also looked like it was a 0. So let's run -1 through. I don't have to go back to the original. I can go down to the cubic here, the third degree polynomial, and run it through and see if it's a 0. Remember, again, this part is your remainder, so I don't need to carry it down. I've already taken care of this remainder, and it's 0, so there's nothing to carry down. So I only need to focus on this part. I'm going to circle it and erase it real quick. I only need to focus on this part when we run the -1 through. Bring down your 1, multiply, add. Multiply, add. Multiply, add. And notice that we get 0 again. So this tells me that -1 is also a root. We started with a quartic, a fourth degree polynomial. We've run through now 2 divisions. I've divided by x plus 2, and I've divided by x plus 1. So this now is the coefficients for a quadratic. Sorry about the train in the background. So let's just write out our factorization so far. -2 was a 0, so x plus 2 is a factor. -1 is a 0, so x plus 1 is a factor. These are now the coefficients of a quadratic, so the end of this is x squared minus 7x plus 12. Again, we can either use the quadratic formula or factor this. This one factors nicely. It factors as x minus 3 times x minus 4. If you did not see how that factored nicely, then you could use your quadratic formula like we've done in the previous problem. This is, again, factoring the polynomial into linear factors. Linear because each power on x here is a first power. We can also, again, read off the zeros from this. We found 2 of them to start with, -2 and -1. Again, if you were to set this equal to 0, the x minus 3 would give you a 0 of 3, and the x minus 4 would give you a 0 of 4. Let me do one more, and then I will write up solutions for the other ones that I did not do here. Let's see if I can scroll and find another fourth degree one here. I may have done that one in class. Perhaps the fourth. Oh, here we go. Let's do a fifth degree one. That's a long one. Why not? Sounds like fun. All right, so we've got a fifth degree polynomial here, 7x to the fifth minus 37x to the fourth plus 59x cubed plus 7x squared minus 76x plus 20. That was a lot of words. But remember, again, when we do our possible rational roots to start with, we only look at 2 things: constant, leading coefficient. Factors of 20. 1, 2, 4, 5, 10, 20. Factors of 7. 1 and 7. Again, your factors of the constant are your possible numerators. The factors of your leading coefficient are your possible denominators. When we form our fractions. So our possible rational zeros list, plus or minus. We do everything over 1, and we do everything over 7. So first we have 1, 2, 4, 5, 10, and 20. That's everything over 1. And then we would have 1/7, 2/7, 4/7, 5/7, 10/7, and 20/7. That is everything over 7. All right. Now we're ready to put this into Desmos. I'm going to have to flip back and forth because I'm not going to remember that. Maybe I can do it this way. And split my screen so I can actually see it as I type it in. Let me reattach my keyboard. All right, scroll this over. Let's get rid of this. We've got 7x to the 5th minus 37x to the fourth plus 59x cubed, and I've got an extra symbol in there, plus 7x squared minus 76x plus 20. All right, let me maximize this again so we can see. I can see there are 3 places here where this crosses the x-axis that I see immediately, right? This one, again, if I look at this point, there's -1. Let's do this one as 2. So I recognize those pretty quickly. -1 and 2. This one we may not recognize pretty quickly, but remember all of our fractions there were sevenths. And if you type it into your calculator, if you do 2 sevenths, that decimal is 2 sevenths. That 0.28571, and it would keep repeating. That is 2 sevenths. You can check that in your calculator. So I see 3 possible rational roots here that might work. -1, 2 sevenths, and 2. So let's flip back over to our work and try those. I am going to put -1 in first. Sorry about the pause. I forgot what the first one was that we saw in the graph. It was our possible rational root. That was why I paused. All right, so put our coefficients here of our polynomial across the top and do our synthetic division. Bring down the 7, multiply by -1, so we get -7, add -44, add gives me positive, or excuse me, multiply gives me positive 44. Add down, we get 103. We get -103, -96, positive 96, -20. Oops, sorry, positive 20. Then we get -20, and we get 0. So again, each of those are just multiplied by -1. So notice that the numbers here are just the opposites of the numbers here. So we're just multiplying by -1 at each of those steps. We get 0, so -1 is a 0. So we got one of them. We said another 0 was 2. Bring down the 7, multiply by 2, add to get -30, multiply to get -60, add to get 43, multiply to get 86, add to get the -10, multiply to get -20, and get 0. All right, so we've got -1 as a 0 and 2 as a 0. We said the other possible one was 2 sevenths. Notice that I did the first 2 with the integers and then did the fraction. You could do this in any order that you would like. You should get to the same quadratic when you're done. These numbers in the middle might be different as you go through depending on what you started with. I just did it in this order, mainly so that I wouldn't have to multiply by the fraction as many times. That was why I did the -1 and the 2 first. It's not any huge secret. So let's bring down the 7. Multiply by 2 sevenths gives me 2. Add down, we get -28. Multiply by 2 sevenths, we should get -8. Add down, we get 35. Multiply, we get positive 10. And then finally we get 0. So we really do have a 0 there. All right, so again, we started with a 5th degree. We've done 1, 2, 3 divisions, so now we're down to a quadratic. These are the coefficients for a quadratic. So just to write your function to start with, we have x plus 1 because of the -1, 0. We've got x minus 2 because of the 2, that's a 0. We've got x minus 2 sevenths because of the 2 sevenths being a 0. And then finally, we have 7x squared minus 28x plus 35. Again, if you don't see how this factors, you can use your quadratic formula. I do see that I can take a 7 out of every single term, so let me do that. I'm going to put it all the way out in front. You might want to, if you're interested, you don't have to, but you might want to take the 7 and multiply it through this factor, because that would cancel out your fraction, right? You'd get 7x minus 2. You don't have to do that. It's just that if you'd like it a little bit prettier and doesn't have the fraction in it, then you can do that. X squared minus 4x plus 5. Pardon me. Be careful. This looks like it might factor because you can do a 5 and a negative, or excuse me, a negative 5 and a 1 to get negative 4, but that would require that sign to be a minus sign. So be careful. That'd be fooling you that it might look like it factors, but it does not factor, at least using integers. Okay. So we'll use our quadratic formula. Set that piece equal to 0. We would have opposite b, so positive 4, plus or minus the square root of negative 4 squared minus 4 times 1 times 5. Let me make that look a little bit nicer because that's pretty ugly. All over 2 times 1. Negative 4 squared is positive 16. When you take this number and square it, this should always be positive, by the way, because you're squaring the number. Minus 20 all over 2. And now we get 4 plus or minus the square root of negative 4 over 2. The square root of negative gives us an I. Square root of 4 is 2. So you get 4 plus or minus 2i over 2. Break it up into the two fractions, and you should get 2 plus or minus I. So finally, now we can list out the zeros, and we can factor our function completely as a product of linear factors. Our zeros are negative 1, 2, and 2/7. We already found those. 2 plus I and 2 minus I. That's the zeros. Going back up here, I can finish off my factoring by rewriting this as x minus 2 plus I and x minus 2 minus I. Remember again, if a number is a 0, then x minus that number is a factor. So this part right here is factoring it into a product of linear factors. I'll write up solutions for the rest of these and get them posted on Moodle, but hopefully this gives you an idea with me talking through a few of these of how you do these, and we'll do more of these in class tomorrow.